Good evening once again, guys. I hope you guys are doing well. We are going to pick up from where we left off on Monday. And I had started with question 5.4, but I'm going to take it from the top. If you have a query about your data, I was notified that some people did not get their data, but I promise you that my team is working on it. Whoever is supposed to get their data will definitely get their data very soon. So please don't type about you not getting your data in the chat, but rather send questions related to math and science. We are aware that some people are missing their data and we are actively working on it. And I apologize for that. All right, perfect. And then just to remind you, if you have questions, please use the chat function or use the Q&A section of Zoom and then ask your questions and then they will get addressed. Then if you are joining us on TikTok, welcome. We will be carrying on with the past paper that we were working on Monday. This is the November 2023 past paper, and this is math paper 2. All right, I'm going to get started. So they're saying simplify sine 3x plus sine x to a single trigonometric ratio. All right, so that shouldn't be a problem. We know here we can expand this 3x to sine 2x plus x. Then we also have plus sine of x. Then this is all over. I can keep it as cos of 2x for now. Then I will say this is, now this is a compound angle. So we're going to rely on our formula sheet to expand sine of 2x plus x. And your formula sheet will say this is going to change to sine of 2x cos of x and then plus cos of 2x multiplied by sine of x. Okay, now I still have a plus sine x here at the top, sine x. Now I'm seeing something. I want some stuff to cancel out, right, on top because I have a lot going on. So how about I now change this sine x to become, let me just make this small. How about I change it to be sine of 2x minus x. That way, I do have a double angle for sine as well. And some stuff will start canceling out. Because if I expand this part, I am going to have sine of 2x cos of x minus cos of 2x multiplied by sine of x. That's what I'm going to plug in here. I'm going to say plus sine 2x cos of x minus cos of 2x multiplied by sine of x. Okay, now this is all over cos 2x plus 1. Surely there's some things that can cancel out. Let's locate the like terms. Sine 2x and cos 2x, these are like terms, but those ones are not canceling. They are adding each other up. But this and cos 2x sine x, there's a negative in front. Those ones can deal with each other. Okay. Now, let's say simplified, we have 2 sine 2x multiplied by cos of x, and then over cos 2x plus 1. Hope we're still together there. Then what we can do next is we can expand so that we have 2 multiplied by 2 sine x cos of x all over cos 2x plus 1. With an x here, that's my mistake. I hope we're still together there. Now, what we can do is multiply these twos together so that we have 4. Then I'm still going to have sine x and a cos x. Let me see if I say cos squared x. If I have something like that, now down here, I want to change this to become 2 cos squared x minus 1, and then there's a plus 1. That's the double angle for cos. Now we know that there's a negative. We'll deal with that positive 1, the negative 1 and positive 1. Then up there, 4 divided by 2, we know we're just going to have 2. Now, cos squared x and cos squared x, they deal with each other. Then we are simply left with sine x. So 2 sine x is your final answer. I'm not seeing any questions in the chat or in the Q&A. So I think everyone is still fine there. But guys, please remember, if you have questions, if I'm too fast, do talk to me so we can see how we can help you out. Okay. There is something popping up in the chat. Yes, dear?
There's a question in the chat, man.
Okay. So somebody's asking me to re-explain. Okay, I'll go over it again. I just won't cancel, but I'll just explain my working out. So the first thing that we did is, okay, let me just fix this. We have sine of 3x, right? So this 3x is the same as 2x plus x, right? The reason we did that is so that we can expand and use the compound angle for sine. Okay. Now, we know also that x can be written as 2x minus x. The reason we did that is so that we can use the compound angle for sine again, so that some things can cancel each other out, so that we're not dealing with a nasty equation, because you'll find that some things don't cancel if you keep it as sine of x. Right, so sine of x, I changed it to sine of 2x minus x, because 2x minus x is just x. Now, as per the compound formula, compound angle formula for sine 2x minus x will change to become that. All right, now there was a plus here. So this guy is simply what we have here. And then the sine 2x plus x, if you look at your compound angle formula, it will give you this part. Right. The bottom part, I did not do anything yet. Right. Now I said, which ones are like terms? So the highlighted in pink is the same as this. Now they cancel each other out. So this cancels that. What are we left with? We're left with sine 2x cos x, sine 2x cos x. If it's the same and we're adding, it has to be 2 of the same thing. 2 of sine 2x cos of x. This is where I am now. Over the denominator, which I still haven't changed. Right. Now, what is this? Double angle, sine double angle. And that changes to 2 sine x cos of x. I hope we're all together there. Now from there, all I did is I multiplied 2 times 2 will give us 4. Right. Now cos and cos will give you cos squared. The sine is still there. Now here, this is the compound angle for cos. And we can change it to 2 cos squared x minus 1. Then there was still a plus 1. So the minus 1 and the plus 1 cancel each other out. Then cos squared and cos squared cancel each other out. 4 divided by 2 gives you this 2. And the only thing that you're left with is the trig ratio being sine. And that's how we get to the final answer. I hope that is clear. Okay, moving on. Just going to zoom out a little bit. So in the diagram, the graphs of f of x is equal to 2 sine 2x and g of x equals to negative cos of x plus 45 are drawn for the interval. Excuse me. X is an element from 0 to 180. And the coordinates of A are 105 and negative 1. So the first question is write down the period of f. Okay, so we know that'll be 360 divided by 2, which gives us 180. That's the period of f. An easy one, mark there. Now, determine the range of G on the very same interval. Okay, so which one is G? G is, let me highlight it. Remember what I said about range? We write range this way, so that we know we are dealing with the y values. I know that's the wrong way to write a range, but this is just to remind us that we are dealing with the y values. Okay, now, in that interval, that range will be starting at this point here and ending at the point positive 1. Hope we're all together there. So it doesn't mean that y is an element from, we can't say 1 because the graph at 1 doesn't exist for this particular given interval. Hope I'm making sense there. Okay, if you wrote 180 degrees without calculations, yeah, so if you wrote 180 degrees without calculations, that's perfectly fine. You will still get the 1 mark there. I was just showing people that where did we get the 180? It was 360 divided by the coefficient, which was 2. Okay, coming back, sorry. 1 second, let me just close this. Yeah, so coming back to this question, for us to find this value there, what are we going to do? We're simply going to say y is equal to negative cos, right? What is x at this point? X is 0, then plus 45. Right, we know that is actually what? Root 2 over 2, but negative. Right, so y is an element from inclusive negative root 2 over 2 all the way to the highest, which is positive 1 and inclusive. I hope that is clear because they gave us an interval. So we must work not a general one, but in this interval. At 1, the graph doesn't exist, but it exists when x is 0 for this given interval. Okay, I'm not seeing any questions. I think we are all covered there. But if we're not, you're more than welcome to talk to me. Now, 6.3, determine the values of x in the very same interval for which f of x multiplied by g of x is greater than 0. Okay, so if you multiply the two graphs, you are going to run into problems. This is an analysis question, meaning that you don't have to calculate. You just have to analyze the two graphs. So for f of x multiplied by g of x to be greater than 0, it simply means that this one must be positive and that one must also be positive. Alternatively, they must all be negative because negative times negative will give you a positive. Right, so we'll start with them being positive, both of them being positive. Where are they both positive? Let me just erase everything and then just highlight the part where they are both positive. Okay, so I'm seeing that from here to 90, between 45 and 90, they will all be positive. If I said this and yeah, just there, they're both positive. Is there a place where they are both negative? No, there isn't. Right. Now, what is this interval? it must be between what? 45 and 90. So we'll say x is an element from, but not inclusive, because we don't have the equal sign under. I nearly said but including, but we don't have the equal sign under. And so we're going to use a soft bracket and say 45 degrees all the way to 90 degrees. If you wanted to use the between one, where x is between 45 degrees and 90 degrees, that is perfectly fine. Okay. Okay, so somebody's asking, where did I get the negative root 2 over 2? Okay, so what I did is I substituted. So we substituted because we are dealing with the graph of G at this point. It took me back a little bit. So the equation of this graph is y is equal to negative cos of x plus 45, right? What is this? Isn't this the y-intercept? We can say y int x is equal to 0, okay? Because this is the y-intercept. Then we can say y is equal to negative cos of 0 plus 45. Okay, now let's just close that. Find this on your calculator. What will it give you? Your calculator will say minus root 2 over 2. I'm hoping that is clear. That's where we got it from. Okay, now f of x plus 1 is less than or equal to 0. Now, let's try to clean this up. When it's like that, it's a little bit difficult to deal with. So what we will do is we will say f of x is what? Is less than or equal to minus 1. All we did is we took the 1 to the right-hand side. So we want where f of x is what? Is under minus 1. Where is minus 1? I'm going to go to minus 1 and draw a line there. So we want where f of x is under this line that we just drew. Okay, let me just clean up some of the things there. It is going to be this part. Please make sure you understand what I just said. Going back to the question. We took the 1 to the right-hand side, it became minus. That's the first step. Now we can analyze this. We know that the crocodile mouth is eating minus 1, which means that f of x is smaller than minus 1. Smaller than means under. That's why I drew a line at minus 1 and I highlighted under minus 1. Now we can answer the question. Which values are that? This is, just a second. This is from that point there to what? This will be, just give me a second. I'm just doing the addition. 165, yes. So we'll say x is an element from 45, right, all the way to 165. Now, because they put a minus sign, sorry, not a minus sign, an equal sign, I'm correcting myself, not a minus, but an equal sign, we will say hard brackets. Okay, hoping that is clear. Now, next question. Another graph P is defined as P of x is equal to minus f of x, right? And the coordinates of D are k and minus 1 lies on P, right? Determine the value or values of k in the interval, right? X an element between 0 and 118. Okay, so that shouldn't be too much of a problem. Let's first do this. Let's say that P of x is going to be minus, right? The minus is this one. Now, what is f of x? F of x is 2 sine 2x. So 2 sine 2x. Okay, now we have x and we have y. Those are the coordinates that we're given. But now remember something, that we have to split this up. We can say this is minus 2 sine 2x is equal to minus 1. Or we can say this is 2 sine 2x is equal to positive 1. Because remember, the graph does go in the first quadrant and it does come down to the fourth quadrant. Okay. Okay, I'm seeing some questions in the chat. Let me just finish this one up and then I'll go back to 6.3.2. I see a lot of people are asking questions there. Okay, let me just finish this one up. We'll definitely go back to 6.3.2. So once we equate those, it's just a matter of solving where we are going to check the angle at -1 and the angle when we are at 1, right? So this question is 3 marks, so we don't have to use general solutions. We can read it off the graph, -1 and +1. So -1 and +1. Just clean this up. So -1 and +1. Okay, and then +1, sorry, that's +1, and then -1 would simply be at that particular point. Okay. Now, alternatively, if you find it confusing, you will still, it's just that it's going to take time, but you can still do the calculation where you say 2x is equal to shift sign of 1/2. Right? And we know that 2x is simply going to be 30 and x is going to be 15 degrees. And I think that's actually the safest way because it's not very clear to read it. I thought maybe 1 will give us 45, but it's not giving us 45. I thought it would be there on the point where we can read it off, but let's not do that actually because it's not very clear. Let me just erase this one as well. Right, so I'm correcting myself. Let's find the intercept, the general solution, in other words, by saying it's going to be 15. And then let's find the other one. So for the other one, we can simply say sine 2x is equal to positive 1/2. Then it will give us the very same answer. But what we want to do is we want to add the next quadrant, which the difference will be 75. Sorry, which the difference will be 90 degrees. So 90 minus 15, the other part will give us 75 because we simply say 90 degrees minus the 15 degrees, and that gave us 75. So our two answers should be K is equal to 75 or K equals to 15 degrees. Okay. Going back to the question that a lot of people have. Let me just go back there. Hang on 1 second. Okay. Okay, so isn't it 105 instead of 45 for 6.3.2? Okay. Just going to indicate that again. Now, this point is given as 105. Just a second, please. I'm not seeing how it could be 105. Wait, hang on. Just a second. The values of x. Yes, okay. Absolutely right. Thank you for that correction. I'm seeing my mistake. Because they said the values of x in this interval for which the graph is under, right? I drew my line there, right? The first value where it's under is the value at A, where it's 105, right? I mistakenly put 45 there, which was incorrect for 6.3.2. So the first value where it's under, let me just highlight. So this part, that's the part where it's under. What is this x-intercept? Also, what is this x value at the point A? It must be 105. That's the x value at that point. My mistake, I mistakenly put 45. That's definitely my mistake there. Now, for the next part, this is the question. This is where the question that everybody has for me. What we're going to do is, in simple terms, I think the calculation will be the easiest way for you to go about it. To say negative cos of x plus 45 equals to minus 1. And then find the general solution, right? So cos of x plus 45 equals to positive 1. Okay, now we know that, let's just quickly do it on our calculators, of 1, that'll be 0. So x plus 45 is equal to 0, which means that x is equal to 45, right? But now, we must just consider the quadrant where cos is positive, right? And also remember that this graph was shifted by 45 degrees. Okay. I'm just trying to think of another easy way to explain that part, to say, so if I minus, I know that this was, yeah, I think maybe the easiest way would be this. Let's look at this difference here. So the difference here is 15 units, right? And then if we look at the difference here, it must be 50, sorry, not units, but 15 degrees. We went to the right by 15 so that we have 105. So for this part, we need to go back by 15 units so that we go 165. And that's where the 165 comes from. I hope it's clear now. Okay, let's check the Q&A. Okay. I'll repeat it again. We just looked at this point and compared it with the x-intercept. We said we added 15 degrees. Now for the next one, we looked at the x-intercept. We need to subtract 15 from it, and that's how we have the 165 degrees. That would be the easiest way to go about it. I hope it's clear now. I'm not seeing any questions in the chat. I think everyone is covered. Okay. Now moving on to 6.5, just dismiss these. The graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H. Write your answer in its simplest form. Okay, so let's say G of X is equal to, we know what it is. It was, let me just go back up, minus cos of X plus 45. But H is obtained when we say G of X, what? To the left. What do we know to the left? We are going to shift it where? We are going to add. We shift it to the left, but we add 45. So it's X plus 45. Now let's find that. H of X will simply be negative cos of X plus 45, but plus 45. Now this is going to give us negative cos of X plus 90 degrees, which simply means that this is H of X is equal to minus, now cos of, so X plus 90 is in the second quadrant. What do we know about cos in there? It's negative. And then, because it's a cofunction, it has to change to sine of X, which simplifies to simply sine of X. Okay, somebody's asking if it's to the right, we minus. That is absolutely correct. When you shift it to the left, you add. When you shift it to the right, you subtract. I hope that is clear. Okay, now moving on. In the diagram, S, T, and K lie on the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta, and then angle S of TSK is alpha. TS equals to P, is equal to P meters, and the area of triangle STK is Q meters squared. Determine the length of SK in terms of PQ and A. So SK, we're looking for this guy now. Because I have a 90-degree triangle, or I have 90-degree triangles, but I don't have enough information. I cannot use sine, cos, or tan. But what I will do is they did give me something. They gave me the area, right, of STK, the bottom triangle, the shaded triangle. I do have the area. I know that area STK must be equal to half AB and sine of C. But we know that the area is Q. Okay, then we'll just say half. Now, my A, I will make it be P, let it be P, and then B will be SK, and then sine of alpha. We are looking for SK, so multiply both sides by 2. 2Q is equal to P SK sine of alpha. Divide both sides by P sine of alpha. So SK is equal to 2Q over P sine alpha. I'm hoping that is clear. I'm not seeing any questions, so I think we are fine there. But remember what I said? The reason we used the area is because we don't have enough information. to use sine, cos, or tan. Okay, now 7.2, show that Rs is equal to 2q tan beta all over p sine of alpha. Now, Rs is the vertical pole. So I'm just going to clean this up and then put what I have. I know that this is 2q over p sine alpha. What is this angle here going to be? The angle is going to be beta because of alternate angles. Okay?
Yes, sir.
Now, is you?
Homoto is asking, may you please repeat 7.1? Are you repeating it there?
Okay, no, I was doing 7.2 now. I'll quickly just re-explain 7.1. So what they gave us is the area of the triangle STK. They said it's Q meters squared. Right? How do we find the area of a triangle that is not 90 degrees? We can't just use half base times height, but we have to use half of AB sine C. So the area of STK is given by this. That's very important. It's not 90 degrees. It's the shaded triangle. Okay? Now, but what do we know about that area? It was given, they said it's Q. That's why I substituted Q there. Half is just half, right? Now, remember for this area, we want two sides and the angle between those two sides, meaning that we are looking at this and that. Okay? So we'll say half. One side is P. The other side, that's the side we're looking for. It's just SK. What is the angle between those two sides? It's alpha. And we have to say sine of alpha. Then from there, I want to get rid of the half by multiplying both sides by 2. So if you multiply by 2, the half is going to cancel on the left-hand side. You're going to have 2q. Then this is equal to psk multiplied by sine of alpha. Then what we want is to get rid of the p and the sine alpha by dividing by them. So on the right-hand side, we're left with sk. Then on the left, we have 2q over p sine alpha. That's how we got it. I hope it's clear for everyone. And as I was saying, was just putting in the information that I just found. Now I have a triangle that looks like this. This is R. This is S. And then this is K. Remember, we can extract, we can separate these triangles. 3D trig is just a bunch of 2D triangles that have been put in together to make a 3D figure. We're saying that this is beta. Okay. And we know what SK is. It's 2Q over P sine alpha. Okay. Now, what we want to do is we want to find RS. So we're going to say this is opposite over adjacent, right? So we're going to say tan of beta is equal to the opposite side, which is what? Which is RS, over the adjacent side, which is 2Q over P sine of alpha. Okay, I think there's a question, unless it's an old one. Okay, what is the angle of elevation? What is the angle of depression, right? So think of it this way. The word elevate means that it's going up. So when you are on the floor looking up, that is an angle of elevation because you are looking up. But let's say you're on the top of a building and you're looking down. That is depression. That is the angle of depression. That's the difference between the two. That it just depends where you are. Okay, now we still want RS. So what I'm going to do is I'm going to say this is tan of beta is equal to RS divided by 2Q over P sine of alpha. Okay, tan of beta is equal to, let's fix this. tan of beta is equal to RS multiplied by P sine of alpha over 2Q. Now it's quite clear from there, because we divide both sides by P sine alpha over 2Q, such that RS gives us 2Q tan of beta all over P sine of alpha. Okay, I'm not seeing any questions. I think everyone is clear on that one. Now, 7.3, calculate the size of alpha. Right? If alpha is less than 90, RS is 70, P is 80, Q is 2,500, and beta equals to 42. Okay, so let's say, let's plug it in this way. 70 is RS, right? Now I'm going to say that 70 is equal to 2. So I'm just plugging it into this formula here, the formula for RS. Okay, so Q, they said it's 2,500. Then 10, what is beta? It's 42 all over P, I should have it, it's 80, and then sine of alpha. Hope everyone is with me there. Now it's just a matter of solving. Cross multiply. Yes, dear.
There's a question there in the chat.
I think the last question is the angle of elevation. I did answer that one, unless I'm not seeing the new question.
Oh, okay. I was disconnected for a time there.
Okay, all right. No, I did answer that one. Thank you. All right. Then what we have is 70 times 80 sine alpha is equal to, can say 5,000. 10 of 42 degrees. Then divide by 70 times 80. So that this cancels that. And then alpha will be shift sine of 5,000 tan 42 over 70 times. That's not a dot, it's a multiplication. It's not a comma, sorry. Okay. And on our calculators, that should give us 53,51 degrees. Please always do these with me so that you can check and correct my mistakes. I do make mistakes, but I'm going to try to be very careful so I don't make any unnecessary mistakes. Okay, no questions in the chat. I think we are fine. Okay, now O in the diagram, O is the center of the circle. Use the diagram above to prove the theorem, which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. That is, prove that TOP equals to 2 times angle K of TKP. Okay, so with this one, the first thing that you have to do, okay, I'm seeing a question in the chat. Okay, somebody's asking me to repeat before we do that one. So I'll just briefly go over it again. All we did is we took RS, the formula for RS, and we substituted the information that they gave us. They did say that Q is 2,500. That's what I substituted. here. Right, and they did say that beta is equal to 42. They also gave us a value for P, which is 80. That's why I have an 80 there. They also told me that RS is 70. That's why I've substituted RS to be 70. So the first part is substitution, purely substitution into the equation for RS. Nothing fancy. Then the next thing that I did is I cross multiplied. Remember, this is over 1. So this multiplies there, and this one multiplies there. That's why I have 70 times 80 sine alpha is equal to 5,000 multiplied by 10 of 42. Then I divided both sides by 70 times 80 on the left and on the right-hand side. So on the left, they need to cancel. Okay? Now, because I want to find alpha, we take shift sign of whatever we have on the right. That's why I have alpha is equal to shift sign of that big thing. But if you want to clean it up here, if you want to plug this into the calculator, that's perfectly fine. It's just that I wanted to keep an accurate answer. I wanted to have an accurate answer at the end of the day without converting. But you can do that. Maybe if you're going to convert it to a few decimal places, use 4 to 5. I usually use 5. Then I convert the last to two decimal places, the last answer to 2 decimal places. So I just kept it as it is. And then this is purely calculator work. Sorry, this is just purely calculator work. I'm hoping that is clear. Now, as I was saying here, the first thing that we need to do is we need to construct. Okay, so we're going to say you have to draw, right, KO, right, so you're going to, it's not the cleanest, but let me do it this way. Right, so tell them, draw KO produced. Right, so that we know that it just goes over, right? So that at least we have a few angles. Okay, now we're going to say that this is K1 and this is going to be K2. Okay, so this is 1 and that is 2. Now, even our O is going to be separated to O1 and O2. Hope everyone is with me there. Then what do we know about O1? We can say that O1 is equal to what? It's equal to angle K1 plus angle T. What is the reason? This is the... Is there a question?
Yes, Stefan. I'll check on the Q&A.
Okay, if you say join KO to produce a certain alphabet, the question is not very clear. If you say join KO, I'm trying to understand your question. To produce, I think maybe what you want to say is you want us to put maybe a certain letter here. Let me say Z, why not? So join KO to produce KZ. That's fine if that's what you mean. If you mean produce KO such that it becomes KZ, that's perfectly fine. It means that you have this in at the letter Z. Okay. I think they're covered now. Now going back to our proof. So this will be the exterior angle of a triangle. Now, what do we know? We can then say that K1 must be equal to angle T. Why? This is angles opposite equal sides. Remember, this is a radius. OK is a radius and OT is a radius. So we are dealing with an isosceles triangle there. That's why K is equal to T. Okay, now we are going back to this equation. So we can say O1 is equal to K1, right? Instead of saying T, we know that T is equal to K1. So it means that O1 is actually 2 times K1. I hope that is clear. We're going to do the same thing for the triangle on the right side. So I'm going to say that O2 is equal to K2 plus P. Exterior angle of a triangle. Please put that reason. Then we know that K2 is equal to P. Why? Because we have a radius and another one. So now we are dealing with this triangle. It's an isosceles triangle as well. So K2 is equal to P, angles opposite equal sides. Now this simply means that O2 is actually what? Is actually 2 times K. Right, but K what? K2. Now, we're going to say O1 plus O2 must be equal to what? 2 times K2 plus what? Plus 2 times K1. Now, this is the same as 2 times K2 plus K1. We just took out a common factor of 2. Now, it's quite evident that angle O of TOP is equal to 2 times angle K of TKP because of the 2 that is in front. Remember, this is O1, then O2 is just 2 times that. Okay, there's a question. So what if you say base angles of an isosceles triangle are equal? That's perfectly fine. Can use that. Okay. Now moving on. Zoom out a little bit so we can see the full question. In the diagram, O is the center of the circle and ABCD is a cyclic quadrilateral. OB and OD are drawn. Okay. So we know those are radii immediately. Now, if angle O1 equals to 4x plus 100 and C equals to x plus 34, calculate given reasons the size of x. Okay. So O1 plus 4x, no, mistake. I just want to state the given one. So O1 is equal to 4x plus 100. We know that this is a given. Okay. Now, if O1 is that, we can say that A is equal to half, because angle at the center is twice angle at the circumference. So we're looking for angle at the circumference, it must be half of the one that is at the center. Okay, so this will be 2x plus 50. Okay. Now, C is given. What do we know about A and C? Okay, not the political party, but A and C. So A plus C must give us 180 degrees. What is the reason? Opposite angles of a cyclic quad. Now we can simply say that 2x plus 50 plus, what is C? X plus 34 is equal to 180 degrees. Now 3x plus 84 equals to 180 degrees. And it's just a matter of simplifying. 3x is equal to 96. Then x must be equal to 32. I'm not seeing any questions in the chat. I think we are all covered. But if we're not, please do talk to me. Next question. Okay, there's a question in the chat. So will I be wrong if I find O2 and equate O1 and O2 to 360? Let me just go back. If I find O2, no, that should still be fine. That should still be fine. Because we are given the angle for C. Yeah, you can find O2. That's the alternative way of working out what X is. Okay. Now, in the diagram, hope we're done with that one. Yes, we are done. Okay, so in the diagram was the center of the larger circle, and OB is the diameter of the smaller circle. Chord AB of the larger circle intersects the smaller circle at M and B. So this is very important. OB is the diameter of the smaller circle, meaning that immediately I can say 90 degrees. Angles in a semicircle. Okay. Yeah, in the chat. Thank you for that, Shurifato. Then can say that OMB equals to 90 degrees. Why? We can see angles in a semicircle. Okay, get 2 marks for that. Okay, there's a question in the chat. So the reason angle at center is twice angle at the circumference is it necessary to state when finding angle A? I think this is the previous question. Yes, it is very much necessary to use that. You have to state that. Remember, you usually get 2 marks, 1 mark for the statement and 1 mark for the reason. So please give them all the reasons. Now, if AB is equal to 300 units and OM is equal to 5 units, calculate giving reasons the length of OB. All right. Now,
7.
yes, dear.
Let's take the Q&A. There's a question there.
If you say 90 degrees perpendicular, because 10 is perpendicular to radius, no, we can't say 10 perpendicular to radius because which one is the tangent? Which tangent are we talking about? AB is not a tangent to neither circle. And which one is the radius? But what we can say is line from the center bisects the chord at 90 degrees because line from the center is OM, right? Because it does bisect But actually we can't use that because we don't know if it bisects at the moment. They did not say that it bisects that chord. So the safest one to use is 90 degrees angles in a semicircle. Okay, there's a lot of questions in the chat. Let's just address them before we carry on. So what about OM is perpendicular to AB? OM is perpendicular to AB, but how do we know? We don't know that OM is perpendicular to AB. Is that given maybe? No, it's not given. So we can't just say that. What about angle from center perpendicular to chord? So angle from center. So that doesn't make sense. We're saying an angle from the center is perpendicular. An angle is not perpendicular, but lines are perpendicular. Radius perpendicular to chord. No, we can't say radius is perpendicular to chord because it doesn't necessarily mean, so think of it this way. If we have a chord there, right, and this is a radius, they're not perpendicular to each other. So we can't simply say radius is perpendicular to chord. Okay, then line from center. Line from center is perpendicular to the chord. Yes, that is acceptable. We could say angle subtended by a diameter. Yes, that's correct. We can use that one. OB is our radius. Yes, yes, OB is definitely a radius, but it doesn't help. It's the radius of the bigger circle. But we have discussed a few reasons that you can use there. So I think we definitely can move on. So calculate OB. So what we want to find ultimately is that. Let's see if I can activate this. Okay. We know that AB is given. So AB is equal to 300. Okay. We can use Pythag because we know that OM is 5. Okay. We know that MB is equal to half of AB. So half of 300, root of 300. Calculator work, that should give us 5 root 3. Please correct me if I'm wrong. For this, we can use line from center is what is perpendicular to the chord. Now we're winning because we have a triangle that is 90 degrees. Then we have MB as 5 root 3. We have OM as 5. And we're looking for OB. This is O, B, and M. I can simply say OB squared is equal to 5 squared plus 5 root 3 all squared. 25 plus OB is equal to 10 units. Okay, let's address the questions. So in the Q&A, what is the reason? I did give you the reason. Line from center is perpendicular to the chord and it bisects the chord. Line from center is perpendicular to the chord and it bisects it. Okay, then in the chat, OP is the radius of the bigger circle, the diameter of the smaller circle, yes. So if your reason midpoint, is it fine? Yeah, midpoint is very vague. Give me something more than just saying midpoint. Midpoint does not necessarily mean anything. What's midpoint? So we need you to be more specific, please. Okay. Moving on. In the diagram, ABCD is a parallelogram with AB is equal to 14 units. AD is produced to E such that AD over DE is equal to 4:3. EB intersects DC in F. EB is equal to 21 units. Okay. Calculate with reasons the length of FB. Okay. Now, firstly, which lines are parallel to each other? If we're looking for FB, we can use the triangle to the left, triangle EAB. So we can say that FB over EB must be in the same proportion as what? We said FB. So we must then say DA, not O. We must say DA over what? Over EA. So I said that FB, please make sure that you are with me every step of the way, over EB, over the longer one. Must be in the same proportion as AD over the longer one. That's all we did.
Yes, man.
Yes, dear.
Are there questions in the chat?
Okay. Oh, yes, thank you. So in the chat, they're just alerting me that I forgot to give a reason for Pythag, which is perfect. So for this part, because I'm using Pythagoras, right, I have to say, I just forgot to give you that reason. Thank you for that. Okay, now I was just showing you those. If you can see it, now we have to give our reasons. Let me not forget it like the previous question. So the reason will simply be proportionality theorem. You don't have to write it in full. You can simply say proportionality theorem. Why? Let's state the parallel lines. DC is parallel to AB. Okay, now let's substitute what we have. We are looking for FB, so we know immediately that we don't have it. But we do have EB, so I'll say FB over 21 is equal to, now DA, do we have DA? No, we don't have DA, but we have, just locate it again. Okay, so AD AD over DE. Okay, we have this. Meaning that I can say this can be 4x and that can be 3x. So that I can say 4x over 3x. Hope everyone's still with me. Okay, there's a question in the chat. Let's see. Oh, yes, yes, thank you. I'm making a mistake because I took the longer side. It mustn't be 3x, my mistake. Yeah, if you can see my mistake, thank you for that. 7x, because I didn't take the ratio of ED. I took the ratio of AE or EA, and EA must be the sum of these. Thank you for that correction. Now, FB will be equal to 4x over 7x multiplied by 21. Okay, then x and x. Then if we just multiply 4 over 7 by 21 on our calculators, we should be getting 12 because the 7s cancel each other out. 4 times 3 will give us 21 units. Okay, no questions in the chat. I think everyone is still fine. Now prove with reasons that triangle EDF is similar. Right? So I always say the straight lines going up are similar. Okay. Okay, there's a question in the chat. Okay, so please re-explain. So 9.1, we are looking for FB. Okay, because we're looking for FB, let's just locate it first. It is this line here. What can help us calculate that? I'm immediately seeing that I have parallel lines. Okay, now because I have parallel lines, I can use the proportionality theorem. Because DC is parallel to AB, I can say that the line FB over EB, this long line, is in the same proportion as line DA over AD. What's the reason? The reason is the proportionality theorem. Simply because DC is parallel to AB. That's the first thing that we did. We didn't say that if B, somebody's saying, how come if B be equal to EB? No. We didn't say that they're equal. Okay, I see what you're saying. It's a silly mistake. Yes, sorry. It must be 12 units. I didn't use a calculator to calculate that. 3 times 12. I said it's 12, but I wrote 21. My mistake. They're not equal. It's 12 units. Okay, going back. Thank you for the correction, but going back, we used the proportionality theorem. We said if B over EB is in the same proportion as DA over EA. Now we substituted what we have, right? If B is unknown and EB is given, 21 units. That's why I substituted EB to be 21 units. It's given. Now, they said that AD to DE is 4:3. Okay. Now, this is the same as saying AD over DE is equal to 4:3, right? That's why we can say for DA, right, or AD, we're going to use 4 times some factor X. Now, we're looking for EA. EA is what? EA is ED plus DA. What is ED? 3x. What is DA? 4x, and then the total gives you 7x. That is where the 7x is coming from. The proportions are exactly the same. Okay. Now I multiply both sides by 21 so that I can find FB by itself. So FB is equal to 4x over 7x multiplied by 21. Then that's the mistake that I made. I said it's 21, whereas it should be 12. It was a silly mistake on my side. The final answer is 12. 4 over 7 multiplied by 21. It should give you 7. Sorry, it should give you 12 instead of 21. Let's just double check. 4 over 7 times 21. Yes, it gives you 12 units. I think we're all happy with 12 units. Okay, hope it's clear. Now prove with reasons that EDF is similar to EAB. Okay, let's clean it up and see. So EDF is similar to EAB. We need to prove that. I'm going to zoom out a little bit. So let's say in triangle EDF, and EAB, what's common? The angle E. It's the same for both of them. So we can see E also common. Okay. Then we can say that angle EDF must be equal to angle A. How so? Look at this part here. Now I'm going to erase. We know which triangles we're looking at. Remember, we dealt with the X fuzz. This is the F part, where this angle here is equal to that angle there. Those are corresponding angles. So corresponding, just push it to the side. Corresponding angles Y, DC is parallel to AB. Okay, now what else can we say? We can say that angle EFD is equal to angle FBA. Right. The same reason, the F is looking the other way now. Let me just clean it up and show you guys. That's the problem with geometry. If you don't see it, you get it wrong. So here we go. These two angles must be equal to each other. Corresponding angles again. Hope we're together there. Right. The reason is corresponding angles. Then as you can see, we have what? Angle, we have angle, we have angle. So we are going to conclude and say what? Triangle EDF is similar to triangle EAB. Why? Angle, angle, angle.
Yes, Papa.
Yes, Theo?
Check the chat there.
Yeah, I'm looking at the chat. Third angle of a triangle, that is perfectly fine. You can use it. Because you've proved, provided you've proved that the first two are equal, then the third one obviously will be equal. That's perfectly fine. Okay. Just quickly recapping, we said that angle E is equal. Okay, or angle E is common, not equal. It's a common angle for the two triangles. Then we also said that angle EDF is equal to angle A because of corresponding angles. And then which other one? We said that angle F is equal to angle B because of corresponding angles again. Because we have three angles, we can say angle, 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 and we can say they are similar. Okay. 9.3, calculate with reasons the length of FC. Okay, usually if they ask you to prove similarity, we are going to have to use the similarity or the congruence that we just proved for the next question. And let's see what's happening. So we want FC, that part over there. I'm simply gonna just erase this so I can write it here. So because we proved that these are similar, right? So it means that lines are in proportion to each other, only because these two triangles are similar to each other. All right. Now, we can conclude that DF over ED is in the same proportion as ED over EA. If you want to put that reason there, that's perfectly fine. Similar triangles. Okay, now that we have that, if C so what I'm going to do is I'm going to say that DF is equal to ED over EA multiplied by ED. What am I doing? Sorry, I'm making a huge mistake here. Let me just fix it. If you can see my mistakes, please do correct me. If C. So if I say if DF over DF, yeah, this is not going to work. Let me just correct it. Sorry. DF over AB. Maybe there's a correction in the chat. Let me just look at the chat. Yes. Yep. Thank you. I've just seen my mistake. Thank you for that correction. So it's DF over AB must be equal to what? To ED over EA. Because we've proven similarity, I repeat, because we've proven similarity, they are in the same proportion. Now let's substitute what we have. So DF is equal to ED over EA times what? Times AB. Then substitution now. So ED, we can use 3x. EA, we can use 7x. Yeah, we used it before. Then multiplied by AB, which is given to be 14. Then calculator work, the x's cancel each other out. 7 times 2, 7, 7 cancel. 3 times 2. We should be getting a 6, not a 2. Yes, 3 times 2 gives us 6. This is, I don't know why it changed it to an O. It's not O, it's DF. No. Sorry. There we go. Okay. Now we're not done. Because we found DF to be 6, we know that AB is 14. So if this length here is 14, what must DC be as well? DC must be equal to 14. Those are opposite sides of a parallelogram, which means that FC will simply be 14 minus 6, which gives us 8. I hope that is clear. Okay, no questions in the chat. I think we're all covered there. Okay, just zoom in. In the diagram, PQRS is a cyclic quadrilateral. PQRS, okay? Such that PQ is equal to PR. PQ is equal to PR, okay? I just want to put that there in PQ and PR. So these are equal to each other. The tangents to the circle through P and R meet QS produced at A. QS produced at A, okay? It's fine. And then RS is produced to meet tangent AP at B. PS is produced to meet tangent AR at C. PR and QS intersect at M. Okay, there's a lot happening here. Now, the first thing that they're saying is prove given reasons that S3 is equal to S4. So we need to show that this angle is equal to that angle there. When you have such complicated things, I think you can rely on Dr. Cape Town, just so that you can give all the information that you can see, your centers, your cyclic quadrilaterals, your diameters, all those kind of things. Okay. Let's say because we have an isosceles triangle, PQ is equal to PR. This simply means that this angle must be equal to that. And then, no, it's not equal to that, but this angle is equal to R3 because of the isosceles part. So, okay, there's a question in the chat. PQ is equal to PR. PQ. I see. Thank you for the correction. Yes, it wasn't going to work out. So I created the wrong lines. PQ, as per the statement, PQ, PR. So these two lines are equal to each other. Now I can say, if that's the case, if those two lines are equal to each other, I can say that R3 is equal to PQR. Right. The reason is angles opposite equal sides. Hope we're all together for that one. Now, we can also say that S3 is equal to is my cyclic quadrilateral. S3 must be equal to PQR. Right? That is the exterior angle of a cyclic quad. Hope we're all together there. Now we can conclude that because they're equal to PQR, I can say S3 is equal to R3. Okay. Now we also know that R3 is equal to, if you look at the bow tie, R3 must be equal to S4. What's the reason? Angles in the same segment. Q and G. I hope that is clear. Now, because I have R3 on both sides, I can conclude that S3 is equal to S4. We're not together, please do talk to me. But no one is raising any questions, so I think we're still fine. Now prove that SMRC is a cyclic quadrilateral. Okay, so SMRC, let me just clean it up. I just want to locate it. SMRC. Oh, sorry. Okay, let me just do it over here. Now remember that AR is a tangent, okay? If AR is a tangent, we have a chord, just gonna erase. We have a tangent here, and we have this chord, okay? So we can say that oh, sorry, there we go. We can say that R1 plus R2 must be equal to PQR. So this must be equal to that. Why? Tan chord theorem. Please write tan chord theorem, not TCT. Hope we're still together there. Then we can also say S4 is equal to PQR. This was proven. Okay. Now, can conclude that S4 is equal to R1 plus R2. So I'm simply, instead of writing PQR, we know that PQR is R1 plus R2. Then we can conclude that SMRC is a cyclic quad. What's the reason? This would be the converse exterior angle of cyclic quad. Okay, let me just quickly recap for those who did not get it. Okay, Shirifat is saying, why don't you say ARP instead of R1 and R2? You can say that. It doesn't matter at all. You can say ARP, that's perfectly fine. So quickly recapping. So I said that R1 plus R2, so this angle here, must be equal to Q1 plus Q2, or in other words, PQR, because of the tan chord theorem. There's the tangent, here's the chord. Tangent, and then here is the chord. Now next, we know what S4 is, because in the previous question, we had to find S4, right? We know that S4 is equal to S3, and those are equal to PQR. That's why I was able to simply say that S4 is equal to PQR. It was proven, right? Now, it's just a matter of saying these are equal, because they're both equal to PQR. So S4, it's just located. So S4, this angle here, must be equal to R1 plus R2. Because which one is the cyclic quadrilateral? SMRC. So SMRC. Because S4 is equal to R1 plus R2, SMRC must be a cyclic quadrilateral. The converse, because we use the external or the exterior angle being equal to the opposite interior to prove that this is a cyclic quadrilateral. I hope it's clear. Now, lastly, RP is a tangent to the circle passing through P, S, and A at P. So RP is a tangent so this circle is passing through PS and A, PSA. Let me see if I can just move this. No. But I think we can all see it. It doesn't want to move. It's fine. Let me just erase. This is at angle P. Sorry, at P, RP must be that tangent. So this must be the tangent to the circle that I just drew. Okay. let's see what we can do. So firstly, let's say that S3 is equal to R2 plus P2. So those are angles. Right. What would the reason be there? The reason would be exterior angle of a triangle. So S3 is equal to R2 plus P2. Please make sure that you're with me every step. Now, the next thing that we can say is S4 must be equal to P1 plus A2. The same reason, exterior angle of a triangle, external angle of a triangle. Now remember that we proved that S3 and S4 are equal. So we can say that R2 plus P2 are equal to P1 plus A2 angles. Only because S3 is equal to S4. Okay. Now, the other thing that we need to remember, looking at the diagram there, we can say, let me just zoom out a little bit. We can conclude that P1 is equal to R2. That is the tan chord theorem. If that's the case, then we can conclude and say that P2 must be equal to A2. And finally tell them that RP is a tangent why this would be the converse tan chord theorem. Okay, quickly recapping if you missed it. I just drew the circle so that we can see what's happening. The first thing I said that S3 must be equal to R2 plus P2, right? That's the external angle of a triangle. S3 must be equal to R2 plus P2. That's if you look at this triangle here. And the next thing I said, S4 is equal to P1 plus A2. So let's just clean it up so I can highlight those triangles. So S4, P1 plus A2. There we go. The reason is the same, exterior angle of a triangle. Okay, now because S3 is equal to S4, I can equate these two together. That's what I did here. Okay, now we also proved that P1 is equal to R2 because of the tan chord theorem. Let me just clean and show you the tan chord theorem. P1 and R2. So 10 code. Now, if those two are equal to each other, it's like I'm saying that this cancels that. That's why I'm left with P2 is equal to A2. Okay, there's a question in the chat. Okay, somebody answered. Yeah, it's last year's paper. That's the national paper. Now, we're left with P2 being equal to A2. Then we can conclude that RP is a tangent because of the converse tan code theorem. Right, and that brings us to the end of the paper because we proved that RP is a tangent to the circle. There we have it, 150 marks for this paper. Okay, then I think we can definitely end here for today. It is 8 o'clock on the dot. Tomorrow, Mr. Rangaka will be taking you through chemistry so that you can wrap up. But we can definitely end here for today. Okay, there's a question in the chat. Let me just, oh, okay. It was just an answer to that. All right, guys, thank you so much for joining today's session. I think let's all end here for today. We will definitely see you tomorrow. And remember what I said, your data issues, they definitely will be sorted tomorrow. Our team is working on it, and I apologize for that. So we'll see you tomorrow for physics. Otherwise, make sure that you have a well-deserved rest. We'll see you tomorrow. It's only a pleasure from my side. Cheers, guys.